Three things we did for this test. The first one was 4-9. What was 4-9? Yeah, where we used the number line also. That was, what was the topic called though? That was the idea of what we were doing. What was the topic called for section 4-9? Nobody, really? I mean, it was before break, but I'm hoping somebody could remember the word. Francis. Polynomial inequalities. And looks like you have your notes right there, right? Why not look at them? Thank you. Okay, I was hoping somebody would do that. Polynomial inequalities. What does that mean? And Ida already said we made the T-chart and the number line.
Yeah, I do.
Instead of being equal to, it's greater than or equal to.
Yeah, instead of an equal sign, we're really solving a polynomial that's no longer an equation but an inequality. Now, the other thing that we want to remember when we do this, we don't get roots, remember? We get critical points. It's another note you might want to just jot down. You get the roots of the equation, but they're called critical points. And we put those critical points on a number line. We test each region with a number that's in that region in the original. And we see, is it positive or is it negative? We label the region and then shade appropriately based on the original statement from the problem. Okay? So let's do an example of one of those real quick, all right? Let's do an example of one of those. What about something that says x to the third minus 49x less than 0? How do I begin this problem? How do I begin this problem? Take out an x. What is that called again when you take something out? Factoring, or the GCF, right? A lot of the homework problems are it might have been the problem set, I forget which one. The problem set of the homework problems had problems where you needed to factor out a GCF to start it. And if you didn't, it was very misleading. It was like, what do I do? So please don't forget about your GCF as the easy version of factoring. Leaving behind x squared minus 49. And what do you notice right away? What rings a bell in your head when you see this? Austin?
Difference of 2 squares.
Difference of 2 squares. X squared is a square and 49 is a square. And the difference is here because of the minus sign. Okay? Austin, what does this factor into?
X plus 7 times x plus 7.
Very good. And now what we've done is we've identified our factors in the problem, allowing us to use the zero property rule to say, well, each of these could equal 0. So let's go ahead and find those values. This gives me x equals 0. This is x plus 7 equals 0, or x equals negative 7. And this is x minus 7 equals 0, which gives us x equals positive 7. And what are these called again? Critical points. Okay? Critical points, because they're going to become our boundary of our solution set. When we graph in a moment and we have to shade, those endpoints of where we shade, those open circles, are going to occur at the critical points. That's why they're critical in this problem. They're called critical points in calculus because they're points in which the slope of the line changes. It goes from a line that's increasing to a line that decreases. You know, like these maxes and mins, a line that's decreasing to a line that's increasing. In calc, you call those critical points. Same idea here. These are critical points. They're going to change something on our number line. So let's go ahead and draw a number line now. And I'm going to mark those 3 critical points. Now, what am I going to do next? And how am I going to do it? That's the real question. What am I going to do and how?
Well, now you plug a number in from
Good.
in between each quadrant or section. So it would
Pick a number. Go ahead.
be something less than negative 7.
So?
Like negative 8.
And now, Arthur, where do you plug the negative 8? So he's saying, let's test a point in this region right here. Test a value, something in that region, negative 8. Where do you plug that in?
Into like x times 7, x times x plus 7, x times the top one.
So we call this the factor form. So we plug the test point into the factored form. A lot of you are still going back up to the originals. And sometimes that's more work than it looks like. plug it into the factored form, and then just indicate whether these are positives or negatives. So if I plug negative 8 in, this becomes negative right here, because that's negative 8. Negative 8 plus 7 is negative 1, so this is also negative. Negative 8 minus 7 is negative 15, so this is also negative. A negative times a negative times a negative is negative. And therefore, this region we label as negative down here. So when you plug in the point, all you care about is the sign. It doesn't matter what these values actually are. All you're looking for is the actual sign for each of them. Yeah?
Should we show our work when we're testing, or should we just put negative or positive?
Here's what I'm going to tell you. If you are really confident and you do this and you've done this, you have no problem with it at all, and you want to just do what I'm doing in your mind, that's fine. But if you make a mistake, it's going to be tough for me to give you partial credit. So if you feel like, you know what, I want to show my work for testing a point, you're not going to run out of time. Tomorrow's test is short, remember? It's only going to be like a 45-point test. The other ones are all like 80 and 90 points. So it's like a half a test. So you won't run out of time. So if you want to be safe, show the work. But I'm telling you, you don't have to. Okay? But if you get it wrong, it's tough for me to give partial credit. It's like any other problem. How about this next region? What do I test? What do I test in the next region? Liam? Negative 1. Pick a number that's not that large in that region. Well, negative 1 is technically in magnitude, right? Is the smallest number. So in its magnitude, negative 1. So this becomes, the second one becomes, and the third one becomes. So a negative times a positive times a negative, what is that? That's a positive. And that's the only reason, honestly, that I made sure to review those rules. Remember in the beginning of the year we did like multiplication, addition, subtraction, and division, and it was like a joke? We talked about what happens when you multiply three things that are negative, or negative, positive, negative. Because you're going to see it come into play here. How about the next region? What do I test? 1. What do I get?
Positive.
Good.
Positive.
Good. So what does it become?
Negative.
Right? Be confident. Positive, positive is still positive, right? So here's what you do. Start here. Positive, positive is still positive, times a negative is indeed a negative. What do you notice?
There's a pattern.
Yeah, a lot of these are going to have patterns. And when are they not going to have patterns? Who's picked up on it by now? Chris?
When there's like a double root.
Yeah, when there's a double root. Remember how there's a repeated root sometimes? You get like x equals 2 and x equals 2 for the critical points. You get the same critical point twice. When that happens, that pattern will get screwed up. But when there's no critical point, when there's no double roots or multiple roots at all, you should see a pattern. Okay, and this one happens to be negative, negative, and then positive. Okay, very good, Chris. All right. So in these regions, we want to then shade. How do I know what to shade? Because a lot of people are having trouble with this last step. I've seen a lot of homework where the work is great, and then this last step. Tori May.
Well, since it's less than 0.
What's less than 0? Where do you see that?
It says x, like the main inequality.
Good. The expression is less than 0.
It's less than 0, so that means that everything has less than 0. So you take all the negative sections.
Yeah, you shade all the negative regions because negative is less than 0. So you shade the negative regions because negative is less than 0. Okay? Had this been less than or equal to 0, what would be different about this answer?
You would shade in the circle.
You would close in the circles or fill in those circles. Can somebody now tell me what is the solution set answer for this? What is the solution set answer for this graph? For this graph, Dave, you haven't answered one yet. Go ahead.
X is in the set, x is less than negative 7. And
4.
or.
It's a big. Remember this gap? Make it remind you of or. Whenever you see a gap between two solutions, think of or.
Okay. Or x is greater than 0.
And less than.
X is less than 7.
Good. And I'll write it like this, Dave, all right? With the combined inequality. So we've got a region that's everything less than 7. That's the first, negative 7. That's the first portion. Or we could be in the other region where it's between 0 and 7 exclusively. What does that mean? Exclusively. Exclusively. As opposed to inclusively.
Not included.
Yeah, very good. So here, we didn't shade in these circles here. It's exclusive. It's not including, as Chris said, not including the endpoints. Had it been less than or equal to, we would have shaded them in. these would have all been less than or equal to symbols, and it would have been inclusively, you could say. Okay? When you have the endpoints, it's inclusive. When you don't, it's exclusive. Any questions on this topic? This is the gist of 4.9. Okay? This is what 4.9 is. Yeah, Hannah.
Are we gonna have to do it when it's like the difference of like cubes?
You will not have to factor a difference of cubes question on this test. No. For your midterm, that will be a topic for sure because we've learned it, but I'm not, because then I'd be testing you on that when really I want to test you on how you do this. So the factoring, if anything, won't be too difficult. So I'm really trying to test you on your application of the factoring in the inequalities. Okay? Yeah?
Are there going to be word problems on the test?
No, there's not. This is the one test with no word problems so far. Yeah. The last 3 problems that, I always give you 3 at the end. The last 3 are going to be 3 of these number lines. Okay, and you're going to have to do all 3. I'm not going to do a choice because the test is so short. Okay, if I gave you a choice, there'd be no problem with the test. So there's 3 of these at the end. Okay, 3 of them. But that's it for 4.9. Everything else before that is going to be the other stuff. Question or you?
Oh, if it was like a negative root and a negative root and then 2 positive, and it would be next to each other, would it be an answer?
Yeah, it would be an answer still, but it would be. Wait, would you say what?
Would it be and, or would it just be x is less than 7?
Here's what you could do. You could say, so this is his hypothetical is a good question. What if it was like this? What if the shaded answer happened to look like this? You shaded here, open circle. You shaded here, open circle, and then nothing else, right? Something like that. What would this look like as an answer?
I would say that it would be x is less than 0 excluding 7.
Excluding, not 7, but
Negative 7.
there you go. So you could just say x is less than 0, comma, x does not equal negative 7. Close your squiggly. Open it over here with the x, okay? So yeah, that's a good question. What happens when you have that little gap in between? So whenever you have that, you could always do that, okay? Whenever there's like a continued line, ignore this open circle. Think of it as a normal solution. Write down what you have. X less than 0. Then take into account the open circle by writing x cannot equal negative 7. Ida.
If it wasn't a closed circle, would you still say that?
If it was a closed circle, it can equal. If it were a closed circle, it would be in the solution, and so would this 0 here, right? So this would be your answer, and this would not be in the answer if it looked like that.
Okay.
A closed circle is a point. A line is made up of an infinite amount of points. And these are all points. There's tons of closed circle everywhere here. Okay, so let's remember that that's what a closed circle is. So we do include it in the answer key. Good question. Or in the answer set. All right, 5.1 and 5.2. What was 5.1 and 5.2? What was 5.1 and 5.2 all about, Dave? Rules of exponents. Rules of exponents. Let me put up maybe like a complicated one, and that can maybe encapsulate like 3 or 4 of the rules at once. Okay? All right, how about this one? What do I start with in this problem? What do I start by doing here? Summer. Okay, let's distribute the exponent. I agree. Absolutely, because there's nothing else we can start canceling and moving until we get rid of that 2 on the outer part. Summer, follow it up. What do I do when I distribute an exponent? What does it look like?
You're going to make 2x squared plus 4
Careful.
be 2 times 2, because when you distribute it, you multiply it by.
Okay, but it's not 2x to the 4th.
Oh, yeah, 4x.
Yeah, because you have to square the 2 first to give you 4, and then, yes, x to the 4th, because you multiply. Notice she's not adding. Don't confuse that, because it looks like, because 2 and 2 can add up to 4 also, right? It's 2 times 2. It's 2 times 2. Okay, this 2 times this 2 here. Now, when I distribute this 2 to the y part, what do I get, Summer?
6.
Very good. Multiplying them. Good. What happens to my 4s? Everybody. Yeah. Becoming 1 and 1. That's gone. Next, what do I do with the negative exponent portion of this? The negative exponent portion.
You can bring it down to the bottom and make it positive.
Okay? Agreed. Whenever you have a negative exponent, you move it from its location. If there wasn't a denominator, you make one. If you had x, y to the negative 6, it's x over y to the positive 6. You introduce a denominator. That's the common mistake. When people don't see the fraction, they forget that you can move the negative exponent. Okay? After that, what do I do? What's the last step here? Come on, somebody else. What's the last step here? What's the last step? Tori again.
You can cancel the x.
Yeah.
So then it would be x to the third on top.
And then how many y's are in the bottom?
18.
I don't see 18. I see 3 of them, and then I see 6 of them.
Oh, right. I thought because, it was the time.
You're a power to a power, you times them. But when you're multiplying with the same base, you
add them.
yeah. So what do you get?
9.
Good. Okay? Again, please be careful. When in doubt, write it out. This becomes x, 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 x. This x is by itself. Well, one of these cancels with one of these, leaving behind 3 x's. That's this part. Same thing with the bottom. There's really 3 y's here, and then there's 6 of them. Giving me a total of 9 y's right there. Okay? Can I reduce it any further? No. Please don't see the 3 and the 9 and think you can make that 1/3. Those are in the exponents. But I've seen things like that. Be very meticulous on your test. Remember your rules. Let's do another one. Let's do another one. It's a 3 in the front. 3xy squared, z to the negative 1, all over 4x to the negative 2, y to the third, z, all to the negative 2 power. It's combining a lot of different rules here. There's more than one way to start this problem. There's one way that's very easy to start it. And there's one way that's a little more difficult. Can somebody tell me the easy way to start this problem? Okay, and I'll explain why it might not be easy if I get your answer. Hannah, go ahead.
I flip everything, like put the bottom on the top of the bottom, and just put it to the cardboard.
Exactly. That's the easy way to start this. Again, everybody should start these problems this way. The reason being is this. If you try to distribute the negative 2, it's easy with all the variables, right? You just raise a power to a power. But what do you do for the 3 to the negative 2 and the 4 to the negative 2? You then would have to flip them anyway. So start by flipping the whole fraction and make it positive. Okay, so we have, and you don't change any of the values in the fraction. Everything remains the same. Because the outside is what's changing. This is changing to a positive 2 on the outside. So please don't switch your exponent signs right now, because we're not really moving them because they're negative. We're moving them because the outer part was negative. So again, that's the rule of thumb here. As soon as you have a negative exponent on the whole outside of a fraction, please flip it and make it positive. It'll just make your life a lot easier. You could do it the other way, but it's messy and there's a lot of room for error. I'm trying to give you a simpler way to do it. At this point in time, what do I do? To what? Yeah. That 2 goes to the top and the bottom, but the top is comprised of a bunch of factors, and so is the bottom. So that 2 goes to everything now. 4 squared is, and then the 3 squared is 9. But after that, just multiply all your powers. You could have canceled first in the inside part and then distributed the 2 if you would like to, by the way. Yeah, everybody hear me? You could reduce what's going on in here if you want first, and then distribute the 2. Same difference. Let's see. Okay, so we've got some negative exponents still. At this point, what should we do with the negative exponents? Yeah, move them, right? Let's move them around. Can somebody tell me what it would look like when I move the negative exponents around? You don't have to do the math, just move them around and show me where they would go. It's 4 people just to move negative exponents. Are we awake? Are we alive? It's your test tomorrow, guys. Come on. George, go ahead.
So you have 16
y to the sixth. Because you, right?
Yep.
And then z to the fourth.
Okay, again, we're just moving negatives, we're not reducing. Very good. So
over-
so far what Georgia did, she moved this up and made this z to the fourth right here, because this would have a z to the positive 2 and a z to the positive 2. Okay, continue.
Then the denominator would be y x to the sixth,
9, you mean?
9.
Okay. X to the,
X to the sixth, y to the fourth.
okay, and that comes about from moving this down here as x to the positive 4. These two becoming x to the sixth. Notice, Georgia did not move the numbers. The coefficients are not attached to the negative exponent. Please don't move the 16 down to the bottom. And I purposely asked that because I know a lot of people move the 16 with the x to the negative 4. It's not with it. They're separate things. Okay? The final step. What's the final step? Arthur? Simplify. The only thing that can be simplified are the y's, right? So what does it become, the final answer?
16 y to the second, z to the fourth, over 9 x to the sixth.
Yep. Exactly right. So again, there's 6 of them here. There's 4 of them here. These 4 cancel with 4 of these, leaving behind 2 of them. That's the y squared that you're seeing over here in the middle. Okay, z to the fourth carries over, x to the sixth carries down. And that's all we can do. 16 does not have any common factors with 9, so there's no way to reduce that, right? Nothing we can do there. And the other variables are all different, so we leave it at that point. Okay? In your textbook, there's a lot of example problems. There's some that we haven't done still. So when you're studying, you can even go to the chapter test at the end of chapter 5 and look for examples of this. Okay, you can look for examples of just this. What if I had something like this, just to really quickly take a look at this? What if I had a simple example like m to the second over n to the 0 squared times n to the negative 1 over m to the fourth. What if I had something like this? That's a times symbol in the middle. This is not much different, and don't let the times symbol confuse you, because we didn't do multiplication with this yet, but it's not any different than what we've been doing at all. Summer.
And to the 0 is 1.
Good. Anything to the 0 is 1, so replace that right away. Then m squared squared is m to the fourth over 1 squared, which is really just kind of over 1. I'm going to leave the 1 there because I have fractions, right? I'll leave the 1. Times. Now, what do I write this fraction as?
Well, you could bring down the n, so it would be 1 over n to the fourth, n.
Very good. Or nm to the fourth, same difference. Good. So you would bring the n to the negative 1 down, making it positive as n to the positive 1. But what gets left behind on the top is a 1. Okay, don't forget there's a 1 left behind up here. At this point, m to the fourths, what happens to them? They cancel. Because when you have multiplication with fractions, you might as well just make it one big fraction line and put times symbols up here. The m to the fourths cancel, leaving it as 1 over n. Okay? All right, the last section was 5-4. What was 5? You have a question on this?
Yeah.
Yeah, go
If
ahead.
it's adding, is it like the same thing? Like if there was adding?
No, it's not, and we're not going to get to that. We're actually going to hold that off to the end of the year because it's a whole other unit that we're going to graph with those also. So we're going to wait on that. If it's adding, you need a common denominator.
Okay.
That's the problem there. And it's not difficult, but we're going to wait till the end because it has to do with different types of functions that we're going to graph. Other questions on this? Other questions on this? All right, section 5-4. What was the last part about? Dave.
Rational operating expressions.
Which really meant what? In simple terms.
Instead of all multiplication.
Yeah, and we know that there's always going to be a division sign in the middle. That's the key. When they're rational, what does rational mean? Think back to the beginning of the year. A number that's rational can be written as a fraction. These are rational expressions. Oh, you see the correlation? Rational numbers are fractions, really. Rational expressions are fractions with variables in the top and in the bottom, both. Okay, both the top and the bottom. So let's say that the numerator is the following. X to the third, or let's say 3x to the third minus 27x all over x squared plus 8x plus 15. And the question is just to simplify a rational expression. What do I do to start this? What do I do to start this problem? Liam.
Put GCF for the top,
Good, Liam. What do we got?
3x,
Yeah, 3x comes out up top. And what does that leave behind for me?
x squared minus 9.
Yeah, right away, please notice dots, difference of two squares. In the denominator, what do I get? Can I pull out a GCF in the bottom? No, I can't. So just go to factoring.
X plus 5 and X plus 3.
And remember what I told you. If you're reducing an expression, there's a good chance that the factors are going to cancel. So we're probably going to get x plus 3 up top somewhere. And look, we do because of difference of two squares. Okay, so let's do the top, or let's reduce the top now. And what ends up canceling are the x plus 3's. And just write your answer the same way you would write it as if it didn't exist, as if those weren't there. This is your answer. Okay? You could distribute the 3x if you wanted to, back out, but there's no necessity. If it's a multiple choice, then maybe you should distribute it out if you don't see this as an answer. If what's in that box right there didn't show up as one of the answer choices, maybe that means you need to distribute the 3x and find that answer choice. So the answer could be written in any form, and that's why you need to be able to manipulate that form you see it in. How else did we see this application in 5.4? Remember the first example, the word problem I gave you with the electric field intensity? Okay, all that was that I'm telling you that some function is a function over another. And we did one that said like k of x equals h of x over g of x. And I gave you h of x and gave you g of x. You just have to put them in the top and the bottom and simplify accordingly. Okay? So you can see this in a different form. But that's really what 5.4 is about. What can you not do in 5.4? What's the common mistake that I don't want people doing?
Well, when it's like adding, you can't really factor out from the top and bottom unless
Cancel.
you cancel out.
Yeah, you could factor. You want factor. You can't cancel the top and the bottom parts when there's an addition sign. For example, if I go back up to this red part at the top, I could see that, oh, well, there's an 8x and a 27x. Can't I just cancel those x's there? But these x's cannot cancel because this itself is a term. It's an addend with this other one up top. They're not factors. Only factors can cancel. Okay, only factors can cancel. Do you have any other questions about this? You want me to give you the format of the test? Do you have an idea of how many questions to expect? Would that be good? Yes? All right, let me pause this.